Hello, Dhawan sir. Can you hear
Yes, sir.
me?
Hello, sir.
Yeah. It's 7 o'clock in the evening in India. So people have already joined. So I request you to please start your lecture so people can listen it. Those who have already joined on time, so let us respect their time.
Sure,
And
sir. Sure,
people
sir.
who can join later, they can join in between. So let us proceed. And I request and I sincerely welcome all the participants who are very eager to learn this new topic, and we appreciate it. And we are very grateful that Dhawan sir is there to explain all about the clean room design and HVAC. So let us proceed, sir. It's up to you. I hand over to you, sir.
Right. Thank you, sir. Thank you, sir. Good evening, friends. It's evening India time. We welcome you all to this session. Let me assure you that whatever you're going to witness is for the very first time anywhere in the world where you'll get such type of drawings, animations, and explanation step by step. We don't outsource anything. We make our own drawings, we make our own animations, we make our own painting. That is why you'll find that our animations are very, very correct to the requirement of the text. So, welcome to this session. So, we are going to speak.
Sir, I want to add one more thing. Those who have any questions in between the session, please type your questions. So
Yes.
at the end of the session, we can cover up those questions, answer and all. And Dhawan sir also, after every 20 minutes, 30 minutes, whoever joins new, he will also he will also ask them to type the questions. So and say after 1 hour, when we finish the session, we will take a half an hour nice time to answer your questions. Over to you, sir.
Okay. Okay, friend. If you see the first slide, what I'm showing you at the left hand corner, right? That is showing the application. Application of pharmacy, medicines. The person in the middle, right? He's scratching his head. He's talking about standards. We have two standards, ISO and FS 209E. The third is again application. In the bottom left hand corner, you see this chap sweeping the floor. Now that is the dust, right? Clean room is about removing dust. And this bacteria, you see, bacteria is being removed, and we have a filter in between. So how do we limit? We cannot remove the dust. How do we prevent the dust and bacteria from entering our space? That is through a filter. And then the right hand corner, this is a fortune teller. It talks to you about the future of clean rooms. Enormous future of clean rooms. Enormous. Wherever there is electronics, wherever the high-tech in manufacturing, you have clean rooms. Wherever you have medicines, you have clean rooms. Wherever you have operations, we have clean room. So practically, as we say, there is no life without air conditioning, and we can say there can be hardly any manufacturing without clean rooms, right? So you're going to witness a session of clean rooms, which are a very, very bright future. Now we come to the next slide. Just give me. Okay. Now this is about clean room design, right? Now I have shown you garments, I have shown you validation, I have shown this bacteria coming here. And then when you design a clean room, it's all about pressures. What is the pressure in between various rooms? Airlock, ungone room, critical production areas, initial packaging, final packages. You have to take care of the pressures inside that room because you must limit the flow of dust and bacteria. Now, see the topics we have to in our course. We are covering the following topics: clean room application 3, clean room standards 4, sources of contamination and control 5, classification of clean room 6, pharmaceutical standards. This is what we're going to cover in our course material. This is what you ought to know. First is an introduction, second application, third standards, fourth how to control, fifth classification, and then pharmaceutical standards are very, very different, because when you're manufacturing medicines, the level of cleanliness is very different. Now we come to the next slide. And flow rate, air change, airflow patterns, particle migration control, yes, and construction number of it. Now, in laboratories, we conduct certain biological experiments that is called microbes. So that has a different standard. When you're going to manufacture a medicine, special formulas, and you do certain biochemistry, for that we have a special standards. Then the standard for sterilized room, non-sterilized room, airflow rate. What will be the quantity of air coming into the clean room? Remember, if air is going to come in the clean room, dust is going to come in the clean room. What will be the flow rate? How many air changes? Now the level of cleanliness. How many times this air has to be circulated through a filter? Will it be once through or will it be several times? Then what area will a filter cover? Ceiling filter coverage standards are there. Airflow patterns. How will the air flow into the room? Particle mitigation and control. How the particles move around in the control room. And then construction material of a clean room. Basic construction material of a clean room. This is what we will cover in this course material. Filters. You see, there are basically two types of filters. One is HEPA, one is alpha, right? We're not talking about three filters, we're talking about the special filters. When you're dealing with clean room, let us discuss the special filters. Then how do you validate a system that this system is okay, not okay? Does it meet our standards or does not meet our standards? Then you have an instrument that's called optical counter. How do you select an optical counter? People use instruments, but no one ever tells you how you select the instrument. You just can't buy any instrument. No. Optical counters will be different types. Which one would you require? How to select that? Then basic steps for designing a clean room. Finally, you can't enter a room in your normal clothing. There are special garments. How you wear that garment is also important. Garments, gowning procedure means how you're going to wear it. You have shoe covers, you have your main gown, then you have a cap, you have gloves. What is the procedure? And then garment design. No one speaks about, you can't wear any garment. It has to be a special garment. It cannot have loose threads, loose fibers. Then if you have loose thread, loose fiber, then your clean room is gone for 6. It will not work. Then finally, an animation of a typical layout of a clean room with untreated makeup air and with treated makeup air or air handling unit. Now, friends, any of you have any questions as of now, please type your questions and we will talk to you as we go along. We will not leave all the questions for the end. Anybody has any questions, just type your questions and we will move forward. I'll just wait for another 5 minutes. Then, Neeraj, there's a question. Can you please, the chat, can you please see it?
So let us take all the questions in the end. We will just note the questions.
Okay, sir. So we go forward now.
Yes, sir.
Now we come to this introduction. We must remember that an air-conditioned room with a closed space. Dust enters the room through door openings, by fresh air, by human beings, right? So in an air-conditioned space, the level of dust has to be controlled according to the usage of the space. What will the level of dust to be controlled? The type of clean room will depend on the application. Then The level of clean defines the clean room. Okay, now we come to this. Can you see all this? The background music is disturbing me. I forgot to remove it. Now, air contains dust, right? Now, what is dust? Let's talk about dust. Can you see this, friends? Any problem? Let me know. Dust is made of fine particles of solid matter like soil particles. That is dust. Okay. Then we come to the next slide. Pollen. This is a fine powdery substance, typically yellow, consisting of microscopic grains discharged from a flower. This is a pollution coming from flowers. Then you have mold. It's a fungus that takes place on foodstuff as living organism. Then we come to bacteria, and then we come to miscellaneous particles. Now, all these are some of the basic elements that comprise. We were here, gentlemen. Sorry for the disturbance. I don't know what happened. So this is bacteria and miscellaneous particles. So now we move forward. Filters. Now, basically, to remove the dust and bacteria, we use filters, right? And broadly filters. Then the type of filters will depend on the degree of cleanness. And the degree of cleanness is defined in microns and efficiency of the filter. The lower the micron size of the particle, the better the cleanliness. And the efficiency also depends on our requirement. Now, what is the clean room? So we're going to now speak about what is the clean room. A room in which concentration of airborne particles is controlled. We control the level of cleanliness. You see, everything has a unit, right? Everything has a unit. For example, weight, you will have kg or pound. If you have liquids, we'll have liters, right? Similarly, dust in the environment, we must have some unit. What is that unit? We call that unit micron. The size of the dust particle we permit to enter. Size beyond this is not permitted to enter. So that is called microns, right? And the efficiency of the filters. Okay. Next point is the clean room is contained in such a manner to minimize introduction, generation, and retention of particles inside the room. Then there must be some standards. You just can't do anything. What is the standards we normally follow in ISO 14644? The standard we follow. Clean rooms are designed to maintain extremely low levels of particulates such as dust, airborne organisms, and vaporized particles. Clean rooms typically have a cleanness level quantified by the number of particles per cubic meter. So we come to this. What are the parameters controlled by a clean room? Temperature, humidity, sound, vibration. These are common parameters. And what specific parameters? Airflow patterns, room pressure, contamination, microbial contamination, electrostatic discharge, gaseous contamination, process specifics. Now we come to clean room applications. So you see, every slide has some image, some animation to make the subject interesting. Without this, it becomes very boring. So to make it interesting, one. Number two, communication is far better through these images. Finally, retention. You don't have to just mug it up, right? Memorize it with reading and reading. The moment you see the image or the animation, it goes into your brains and it retains there as an information, right? It goes into your software there inside. Clean room applications, first is pharmaceuticals and biotechnology. So this is medicines are shown here, and something is to make medicines. Second is research. These two small scientists are doing some research for research applications. Then we have microdata semiconductors. Now we are going, in India, we're going to big way in defense manufacturing. Now defense manufacturing cannot happen without electronics. We are also going to manufacturing chips. It cannot happen without clean rooms. And if you have clean rooms, you have a massive arrangement of conveyors and this and that. And that level of cleanness has very important for these processes to be correctly manufactured, because dust is going to damage these processes. Manufacturing semiconductors, assembly of electronic components. Then we come to satellites, rockets, missiles, aeroplanes. All these sophisticated manufacturing processes require clean rooms. Then finally, we have miscellaneous applications, right? Food processing is one of them. There are many, many more. Let's talk about food processing. Then we come to another manufacturing is medical devices. You cannot manufacture medical devices without clean rooms, the highly processed equipments. Then we come to automotive spray painting, clean room. Because if dust enters this, then the dust will settle on the paint and the surface will become bad. Then we have operation theaters and an ICU. Now let me show you this in animated form. So now we have the animation out here, right? This is the operation theater. If you see carefully, the fresh air that enters this AHU has to be filtered. It comes through these filters. The room returner has to be filtered. It goes into the HU, and this blower is going to deliver the air here through the supplier ducts. There will be free filter out here, and then we have the HEPA out here. In an operation theater, the entire ceiling is full of HEPA filters, and the clean air is thrown from the top, discharged from the top, and sucked from the bottom. So if there's any dust in the room, it will settle down and go blue. It will not rise. There's no chance of dust being in the environment out here. And then we discharge the contaminated air from here, because if you're going to add fresh air, then we have to discharge the bad air. So that goes for discharge. So this is the operation theater. In this program, we also tell you how to design the lighting also, how the lighting is done. We'll come to that also. Now we come to standards, right? There have to be certain standards now which we must follow to achieve our objectives. ISO 1464. There are two standards. This ISO, those who are dealing with
sir, your voice is breaking. So I suggest that you be in front of the mic so that it will not break. There are some issues regarding
voice. Okay. It's okay.
Now it's okay, but I suggest not to move away from the mic.
Okay. So these are two standards. One is ISO 14644 and FS 209E. Different people follow different standards, but both are same. Now we are comparing. Now this complete comparison is given to you for your reference. At any time you can compare what is what at different degree of contamination, 0.2 micron, 0.1 micron, 0.2 micron, 0.3 micron, so on. The complete table is given to you. Now, these are the latest standards being followed. Now, which standard is applicable there? This standard is for this is for this is for this. All these various standards are for various applications, right? For construction, for testing, for method evaluation, for design, for operations, terms and definition. So all these standards are listed down depending on for what you want to use it for. Now we come. Okay. Now There are two sources, one external source and one is internal source. Now, how do you control them? Filtration to dilution, isolation. The three methods of control. Right, now we go to next. So these are two standards out here. The EU standards are separate. They have their own standards. And FS to the 90 and ISO and the comparison all the three. Now we come to flow patterns. This is one method. Non-unidirectional flow, right? Unidirectional flow. In some cases, the floor is also raised, right? You can see out here raised floor. Then you come to this. Mixed flow and minion pipe. See, for this particular area, the laptop area has special treatment. This is extremely sensitive. So what is extremely sensitive comes here and the rest of the room is out here. There you are. Now, so if in certain cases, this product has to be super protective. So for example, if you're manufacturing wafer of a IC chip, so that is super protective. That is kept here with maybe this is class 10 and this entire room doesn't require that level of cleanness. So as a separate system out. So we have mixed flow. Now how the particles move from positive pressure and the formula involved in finding this. Then we come to how do you between the clean room and the not so clean area, there has to be an airlock. See, there's an airlock between the not so clean area and the clean area. You just can't walk in from the not so clean into the clean without going through an airlock. This airlock will prevent this clean area from getting contaminated. You come into the airlock, you change your clothes, you wear special garments. The entire design is given in the forthcoming slides. If this room is pressurized, this room is not so pressurized, then the doors are not going to open so easily. Because how will you open this? If you notice something, the movement of the doors, look carefully. The door opens to the pressurized area, higher pressure. It will open towards the higher pressure. You force the door open. So when you force the door open and when you leave the door closes by the extra pressure from this side. So these are 3 pluses and 2 pluses. You see that carefully? So if I open towards the 3 pluses and I move away, the door will close because the pressure out here is more than the pressure of the airlock. The door will close. There's no chance the door will not close. Okay. So how do you place the doors? The opening of the doors. Take the case if you're in the passage now. You want to enter this room. The door is not going to open so easily. Right? If you are going to enter, okay, you open the door. Suppose you have some material with you, material with you. For example, you're carrying some boxes of medicines and you want to enter the clean room. So, I'm carrying boxes of the product and you want to enter the clean room. Then you're going to open the door, right? Right? And then you're going to go to suppose the product is in a trolley. You open the door, you go to the trolley, the door will close again. You have the positive pressure. So there is a pressure stabilizer. You open this, then the pressure stabilizes. Then you can bring the trolley in and then close it and the door will close. So this airlock functions as a pocket where it traps all the outside dust, particle, whatever coming and does not permit it from entering the clean room. So this pressure stabilizer is used If you're going to carry material, okay, I have a trolley. I'll first operate the stabilizer, open the door. No, the door will not close. Because I've used this instrument out here. Bring in the trolley, then reoperate this, then the door will close. Pressure will increase out here and close the door. Now there's a filter. This is how. Complete construction of a kappa filter and alpha filter. Now we come about validation. How do you certify a clean room? If you have installed the filters, you run the system, how will you certify that the clean room is as per the standard or not, functioning properly or not? Then this is the method of validation. Certify, yes, the clean room is as per our requirements. So this process is defined out here. How you take it. Just see, everything is absolutely crystal clear. You take this instrument, the anemometer, you have to take 5 readings. I've shown you the 5 readings, how you take it. You take it 2 here, 2 here, 1 in the center, and accordingly we explain to you, right, what should be either velocities coming from this, and then formula is given how to work it out. The leak test, okay. Okay, we explain to you. This is an instrument used for testing the pressure. The complete process is defined out here. Now you have to also test how much light should be there. Now on air conditioning processor, what is we got to do with this? Nothing is complete. You see, to make the system to be operational and complete, all the parameters should be taken care of. Light is also one of them, right? So we are telling you how the lighting system is done out here. Now we have covered all the steps. Step 1, complete layout explained out here. When you come to 3, so the class, so all the classification for various applications is given here. What will be the class of the clean room in with respect to ISO class and FS class, and what is the application? For medical device packaging, your ISO class is 7 to 8 and FS class is 10,000 to 1 lakh. Example is given here. Okay, now we go next out here. PS2 on ungone side. 4. All these symbols are given out here. What is EM? What is PS1? What is PS2? What is this symbol it defines? It's all given out here, and how you will position all these things in the line system. This is the formula of ASHRAE standard 62.1. This is the formula for getting amount of ventilation required. Okay. This will makeup air is not treated. right? Wake up is not treated. Now we come to garments. Now see, the human being is totally covered. Cap, hood, safety glasses, mask, gloves, overall, shoe covers, boots. No part of the human body is exposed to the environment. So, now we can take questions, sir. Neeraj ji? Hello? Hello? Hello?
So
Neeraj
you
ji?
can take questions one by one. You can
Yes,
take
we can take questions now. So what are the questions, sir? Can you see them?
So you can read that. You might be having on your panel.
Myself.
Yeah. And the bottom question answers.
I have chats out here.
Please read.
Can you see those questions? You've got one question now. Hello, I think there's a question from Mr. Pathak. I'm not able to understand exactly what you want to say. I have also purchased your clean room design book. In this book, there is a table about air change per hour, but I have a design of us approved pharma company. So we have taken the air change requirement as per ASHRAE. We have followed the ASHRAE standards. You can, they may have taken something different, but we have taken the ASHRAE standards. Basically is the clean room application. How to determine how much pressure to maintain in the clean room and also pressure difference between each rooms. That will depend. We have given a general procedure how to design. That will depend on the application. What is that product being maintained? You can have a positive pressure. I think we mentioned in the system, it should be some, we have mentioned how much inch should be there. It's there in this book. I think yes. We will get back to you on these questions, right? By mail. So class 7 and 8. We have to refer to what we have written in the book. We refer to that and we'll get back to you on this. Next question. Any more questions? Which books can I purchase? This book is available online. We will give the updated version. The earlier one was the first version. Now we'll come with the updated version, right? Very soon, in a day or two, that will be uploaded on the website for you to refer to. Now, basically, we are telling you what is the clean room about, how to design, but specifics depends on the product, on the application. Different pharma, depending if they're making some vaccine, they may require some other standards of pressurization. It depends on the viruses which they're handling. So generally, what should be the pressure differential that generally has been given out in this book. Alpha is a higher version of HEPA. This is also explained in the book. You can go to the book, you'll get it, what the alpha means. It's very much there. Any more questions? Do we need to measure, this is from Mr. Aslam, do we need to measure the AHU supply airflow rate for the clean room, and what is the function of the measure of airflow as we have we measured differential pressure measurements and pressure regulations TQ. Do we need to measure the AHU supply airflow rate? Definitely you need to measure the airflow supply rate, because you see, if the filter is, what is the degree of contamination of the filter? As you go along, the filter gets contaminated and the pressure will drop. Now, how will you know that the filter is contaminated? You have to measure the pressure across the filter to see whether it requires replacement or it does not require replacement. Definitely you need to measure it. Any more questions? There's one more out here. What should be the minimum pressure difference? You go to the book, you'll find it out. It's in the book. What the pressure difference? You have a design pressure. Let us say you have a design pressure of 40. What should be the pressure outside? Given this in the book. Any more questions? Please mention book name. This is our course material. It will be given on the website. The current one is being upgraded by this one. What you see now, the upgraded one, will be uploaded in a day or two. You'll get the upgraded one. And those who have got the old version will automatically get the upgraded version. You can call it a book, you can call it a course material. We have our own course material. Go to our website and you'll get it. Any more questions? Anybody? Right. I don't think anybody has got too many questions to ask. Basically, what you're asking for is specific issues. Now, specific issues in a manufacturing depend on the product. Right? If you're making a wafer of IC, then you have to refer to the manufacturer, what the manufacturer wants. If you're going for vaccine, then you have to refer to the manufacturer, what the manufacturer wants. These are specific requirements done, but what are the pressure differentials and air change? It's all because depends on the processes